So after all that theory, let me show you an example of using, in this case, a velocity time graph. This velocity time graph describes the motion of a car for 40 seconds of time. We have velocity here, sometimes negative, and this is time increasing to the right. The question tells us to use the graph to determine the car's acceleration during its first 5 seconds of motion, that's here, the times when the car was stationary, and the car's actual displacement at the end of the 40 seconds. So, A and B are easy. The acceleration during the first 5 seconds is the slope of this graph. Now, it's a velocity time graph, so acceleration is the slope. So that is 5 meters per second over 5 seconds, or 1 meter per second squared. 5 divided by 5. B, when was it stationary? It was stationary when the velocity was 0. Be careful. It's not stationary here, it's moving at 10 meters per second. It's not stationary here, it's moving at 10 meters per second the other way. It's stationary when the velocity is 0. That's B. Okay? Which means it was stationary here, again at 20 seconds, and again at 35 seconds. Actually, no, all the way from 35 to 40 seconds. That's B. But what about C? The displacement at the end of 40 seconds. For me to work that out, I'm just choosing a different colour so it's not quite so confusing. How about we go for purple? For C, I'll circle in purple so we know, we have to work out how far it's moved at each of these sections so we know where it is at the end. In fact, as soon as we get here, we know because it hasn't moved in this section. How do I work out the distance? Well, from a velocity time graph, the distance is the area underneath. So let's do this. In this section here, this is a triangle. It's 10 by 10, 10 by 10, which is 100, and I've got half of that, so it moved 50 metres in that section. In this section, it's 10 metres per second times 5 seconds, so it moved 50 metres there too. This section is smaller than that, I think it's going to be half. The velocity changed by 10 over 5 seconds. So 10 times 5 is 50, but this is a triangle, so that's 25 metres. So by the time I get here, I have moved 125 metres. Okay? My displacement after 20 seconds is 125 metres. But now my velocity is negative. So for the rest of this section, I'm actually moving back towards where I started, unless I go past. Let's see what happens. In this section here, the velocity went up to 10 over 5 seconds. So this is the same as that. It's negative 25 metres. This section, that's 10 over here, and that's 5 seconds. So this then is 50 metres, but it's negative as well. And then this last section here, over 5 seconds, it changed again 10 metres per second. So this section is negative 25 metres. So in this whole section here, the displacement from between the 20 up to the 35 was negative 100 metres. So when I get to here, my displacement is the 125 minus the 100. My displacement is now 25 metres. And end of 40 seconds, it's not going to change here because remember it's stationary. Velocity is 0. So at the end, my displacement is 25 metres.